Good morning, good afternoon, or good evening, depending on where you're watching this video from. This video today, I'm going to focus on IBDP past paper questions, mainly paper 2 questions, where you need to master how to use your GDC. Mainly this question, you're going to understand integration, even differentiation, some parts, but the main objective here is to fully understand how you can use your GDC in the paper 2 exam questions. Okay. Now let us start with the question. It's the question we are doing right now has 17 marks. So I would like everyone to see what we're going to do here. So 17 marker question, very good question. That's mostly they are always in paper 2, section B. Now, if x is given as that, show that the x coordinate, okay, of the minimum point on the curve satisfies this equation. See, I'm underlining the keywords here. Okay, that's what I'm underlining. Those are the keywords. Another keyword here in the equation, the domain is 0 to pi. The values of x are defined from 0 to 2 pi. Very important to know that one in the domain. So before I start doing the question, there are a few things I want to review. One of them, when you see it's fx equals 2 square root of x over sine x. In other words, we are dividing two functions, okay? Good. Now, do you remember quotient rule, guys? Okay. The quotient rule is going to be u derivative v minus v derivative u over v squared, okay? That is the quotient rule, where u is the function. U, it is the fx, for instance, is any function. In our context here, it will be square root of x, okay? In this context, okay? Good. Now, v is going to be g of x. You are dividing two functions, that's what I mean. And in our context, is going to be sine x, okay? Am I talking to someone? Very good. Good. Now, that's the first thing. Second thing that I want everyone to remember is they say the minimum point. How do we find the minimum point of a function? Minimum point of a function happens on and on if when the gradient of the function equals to 0. And whenever I say gradient, I mean dy over dx. So whenever they find the minimum point or maximum point, they mean first derivative of a function is going to be 0. Okay, let us dive in the question now. So from the question, our function u, from the function the u, as we said above, is going to be that. So which basically means x power half. Am I talking to someone here? Very good. Now, what about v? V is the sine x, okay? Now, what's the derivative of that? U derivative is going to be, you bring a half in front because it's power rule, right? Okay. Then x, you do minus on the power, which is 1, a half, sorry, minus 1, which will give me negative a half. So by writing this very well, this is the half here. By writing this very well, that means the u derivative is going to be, using rows of indices, is going to be 1 over 2 square root of x, okay? If you are struggling with the rows of indices, I made one video on that, on rows of indices. You can go and watch the video on EK Math Academy, okay? Now, so what's the derivative of here? This is just from the formula booklet and it's the basic, so it's going to be cos x, okay? Now, can I apply the formula right? U derivative v is going to be, why negative? There's no negative in front here. Just some seconds, this is not negative. Okay, good. So it's going to be, the negative was here, not in front. So it's going to be 1 over 2 square root of x. Now, when I multiply that with sine x, I'm going to have, let me put just this one in brackets, sine x, okay? Good. Minus v derivative u. So u is square root of x, so it's square root of x cos x, right? Because that's my v derivative. All of this should be equal to sine squared x, okay? Good. Now, remember the question they tell me, they have told me, they're asking me, show that tan x equals 2x. Keep that in your mind, okay? Now, I need to type that things here, just writing them very well. So here it's over 1, and then I can multiply this one to here by finding LCM. So I'm going to have sine x, square root of x times square root of x, that gives me x times 2 gives me 2x cos x, right? Am I talking to someone here? Good. Okay. Now, all of this over 2 square root of x, square root of x, then sine squared x. Okay. Good. Let me try to explain just something very fast. What happened here? For instance, if I have fraction, just to help you remember some fraction, a over b divided by c. Because if you check here, I have this. Oh, sorry. I have all of this over that, then divided by that. So I have a over b. So divided by c. What does that mean now? This is over 1, so it will be a over b times z 1 over c. So it gives me 1a over bc. Am I talking to someone? Do you understand now? Very good. Now we are talking about, excuse me, we're talking about the minimum point. Minimum point, we said it happens when the derivative of your function equals to 0. So this should be equal to 0. If that equals to 0, that means the whole of denominator will be equal to, when I multiply it here, this is over 1. So when I cross multiply, the whole of the denominator multiplied by 0 will go. So how many will be sine x minus 2x cos x, right? Equal to 0, right? Very good. Okay. Remember, I'm interested in getting tan x equals to that, equal to 2x. So if I take this one, what do I get? I'm going to have sine x equals to 2x cos x, right? Very good. Now, if I divide by cos x both sides, what happened? This cancels out with this, and I divided it here. So what is tan x over cos x, guys? That is tan x, right? So I'm going to have tan x equals to 2x, hence true. Okay, very good. A part 1 is done. Okay, now determine the value of x for which fx is decreasing. So when the function is decreasing, that means it has a negative gradient. So where does my function is going to have a negative gradient? Now, it's going to have a negative gradient. Let me try to sketch it for you because this is a paper 2 questions. And as I told you, the main objective here is to help you master, understand very well how to use your GDC. Now, okay, so let me clear what I have. So I'm going to have, so this is it. So I have square root of x, square root of x over sine x. Okay, sine x, then close the bracket. What was the domain, guys? Do you remember? What was the domain? 0. The values of x are ranging from 0 to pi. So I have to set my window. Oh, here I didn't write my x. So x, good. Now I need to set my window. So my window should be 0. Then the x value is from 0, the smallest value of x. Then the maximum value of x is pi, which is the one indicated here. But let me just show you where the pi is, okay? Now, can I draw the graph? Okay, perfect. That's my graph. So my graph is decreasing. You can see it's visible from here to somewhere here. Then it starts increasing to the minimum value. So we need to know where is the minimum value of our function. That's what we need to do. So how do we find the minimum of a function? We need to do second trace. Minimum is 3. Then minimum is somewhere here. So I go to the left of the point. Somewhere there. Let me just, for security reasons. Okay, good. Now, somewhere there. So the GDC is asking me right bound of the minimum point. Okay, let me just continue. somewhere there. My curve somewhere, it has started increasing, I can see. Okay, enter, enter. So the minimum value, if we check from the graph here, the minimum value of my function is 1.165. So the x value of my function, where the graph is decreasing, is going to be it's decreasing from, remember the domain, guys? Do you remember? It was from 0. So the graph, let me, by the way, remind you the graph, the way the graph was looking like. This is my y-axis, this is my x-axis. The graph was like this. Okay, now the minimum here, the x value is 1.165. 1.165, which is basically, if I round it to 3 significant figure, will be 1.7. So the minimum value is here. So it's decreasing at this value. So what's the answer for here? It should be 0, remember, less x value, which is 1.17, less, oh, sorry, my bad, sorry, guys. X less 1.17. Okay, I hope you have understood, because we are looking where it's decreasing, my function is in the intervals of 0 to pi, is decreasing from 0 all the way to this value, because that's the minimum value. Then after minimum value, we start increasing. Well and good. Okay, then they say the sketch. We have already sketched the graph. I just want to make a comment, one comment here. So when you need to indicate the minimum value, and so it's from 0 to pi. And by the way, you have to see here. So what is sine pi over 2, guys? Sine pi, that would be 0. And any number over 0 does not exist. So basically here, if I'm to sketch it one more time here, this was my y-axis, this is my x-axis here. Okay, this is, oh, sorry, I did it in the wrong place. Just a second here. This is the y-axis and this is x-axis. So my graph will be like this. So you have your minimum value here, and you have to indicate, you have to include your minimum value. You have to make sure that this is 1.17 is indicated on the graph. But also there is vertical asymptote here, and even here, but that one, even if you don't include it, but very important, because you are being HR, you should know that, because still sine 0, this is 0, and even sine 0 will be 0. So you're going to have vertical asymptotes. You're going to have vertical asymptotes at that. So that's your graph, okay? Fast forward, okay? Now, we are trying to do the next question, question C. Question C, okay? They say, find the coordinates of the point on the graph of F where the normal to the graph is parallel to y equals to that, okay? Let me pick that. I'm going to the next graph here, where they say our graph is parallel, the normal to the curve equals to that, okay? Very good. Now, what do we know about the normal line? So the gradient of the normal line, because if they're parallel, the gradient of the normal line should be the same as the one of the curve here, okay? Is going to be -1. So what's the relationship between the normal line and the tangent line? So we know that the relationship between the normal line and the tangent line is -1 over, because they're perpendicular to each other, is this one. Now, me, I'm interested in getting the gradient of the tangent. I will show you the reason why. So the gradient of the tangent will be equal to -1 divided by -1. So the gradient of the tangent will be equal to 1, okay? Now, back to the question, what was the gradient of a function? The gradient was this. That was my dy over dx. Do you remember? This is my dy over dx. So, meaning my dy over dx should be equal to 1. Okay? So, what was it? So, it is the one more time for you to check. Let me see the question. Is sine x minus 2x cos x over 2 square root of x sine squared x, okay? Now, that should be equal to 1. So let me write it here. It's going to be sine x, if I remember very well, it is 2x cos x, all of that over 2 square root of x, then sine squared x. Are we together, guys? Good. Now, this one should be equal to 1 because the dy over dx that gives you the gradient of the tangent line. Now, we are in paper 2, so solving this one will take you ages. Actually, it will be very, very hard because if you cross multiply, you can see you have square root of x. So that's why I said the main objective of this this video is to help you to know how to use your GDC. So now I have to go back to my GDC and then try to sketch that. Okay, I can clear what I have. So come back to this. Y equals 2, clear the function. Which function do I put there this time around? I'm going to put there sine x. So it's going to be alpha. Then this one is going to be sine x. Okay, sine x. Okay, sine x minus. Remember what we have 2x. It's minus. I have to delete. Okay, guys, whenever you delete, don't clear. If you clear, you lose everything. That's why I call IBDP Math. We love mathematics, and even we teach the tricks of in the exams. Okay, when you clear, you lose everything, and when you lose everything, you're losing your time. And time is very vital, crucial, very important in your exams. Okay, minus 2x cos x cos x here. Okay, close the brackets, then move down. What did I have there? I have 2 square root of x, the 2 square root of x. Then I can open the bracket here, put there sine x, and sine x is squared, by the way. Then is the sine x, close the bracket. Then you do power 2, okay? 2, okay? I'm just checking if what I did is okay. Can we double check? What do we have? It was sine x minus 2x cos x over, so sine x, 2x cos x, 2 square root of x sine squared, okay? Let me check in my GDC, okay? Do I have sine x minus 2x cos x? So very important in the exam to double check. 2 square root of x, then sine x squared. Can I sketch the graph now? Okay, but I need to put there y equals to 1. Okay, that is my second function because I have two functions here. I have sine x, this one equals to 1. Okay, so when you sketch your graph, what happens? Okay, sketch the graph. Okay, now the next thing now, as I told you, I'm teaching you how to use your GDC. Now I need to get the point of intersection. Point of intersection, you get it by doing second press, and point of intersection is 5, so press 5, and you just simply do enter, enter, enter. So when I do that one, the point of intersection for x value is 1.96, okay? Because it's 1.957. So to 3 significant figures, it will give me 1.t. My point of intersection of x value is going to be, the x value is 1.96. But the question says find the coordinates of the point on the graph of f. Okay, what I have on the graph here is the y value. So I need to get the x value, I mean the y value, when x is that. Am I talking someone? That's what I have to do. So what do? You just come to your graph very fast for your graph. Then you do f of 1.96. You're putting it in f, in your function, not in your derivative, okay? That's why you have to put that. Basically, you're putting it in this. That's why you have to put that. So when you put it there, because I'm trying to save time. So it's going to be, should I do it down here? Okay, I think I can do it here very fast. So when you put it there, what are you going to get? It's going to be square root of 1.96, all of that over sine 1.96. Okay, some seconds, guys. Okay. Now, when you work out this in your GDC, what do you get? Second quit. So when I do that one, I'm going to do second fraction is going to be square root of x, and my x is 1.96 over sine 1.96, cross the brackets, right? So what do I get? I'm going to have 1.513. So basically here it's 1.2, 1.2. Back to the graph, I have 1.5. Okay, so three significant figures, 5, 1. So the coordinate of the point here, if I'm trying it here, let me call it point P, is going to be 1.96, comma 1.51. Okay, you have got your 4 marks. I hope you have understood. Very good question. Now, the last part of this question, consider the region bounded by this function x-axis in the interval of this. Be careful with that one. Okay, and rotated through 2 pi radians about the x-axis. Okay, find the volume. That's volume of solid of revolution, and volume of solid of revolution is the b about x-axis. By the way, is that one? It's in the formula booklet. You can check that. Okay, because I want to try to write fast, but sorry. Okay, integration of a b y squared dx. Okay, now in our context, so it's going to be v equals to pi integration. If you check the limits, what did we have as the limits? They said pi over 6 and pi over 3. Okay, now that means here it will be pi over 6, and then this is pi over 3, and then y, my y is the square root of x over sine x. That's our function, which is y. Then squared. Okay, do you get that? Then dx. Okay, just tidying up things very fast, and then I do it in the GDC. So it is the pi integration of pi over 6, then pi over 3. Okay, guys, pi over 3. Now, when I square that, that will give me x, right? Because square root of x squared. Then this one will be sine squared x dx. That's my function. That's the one I have to integrate. Okay, that's the one I'm integrating, right? Very good. Should we do that in our GDC? Guys, are you ready? Good. Let us do it in our GDC very fast. I clear everything. So where do we find integration of our GDC? We find it in math, and it's 9. Okay, click there. So my values is going to be pi over 6. Oh, my bad. Sorry, one more time. It's going to be math 9. So I'm going to have this, right? So pi. Why? Okay. It's going to be pi. Oh, a second. Sorry, that was the mistake I was doing. Okay, pi over what? Pi over 6. Now, what about up here? I have pi over 3 altogether, guys. Good. We're almost done. Okay. Okay, good. Now, what do we have in brackets? We have square root of x. So it's going to be square root of x. No, x only, guys. Okay, we have x. Good. Let me double check. So we have x. Okay, good. You see, we have x over sine squared x. Okay, good. What do we have? We are going to have x over over bracket sin x, close the brackets, then power 2, then dx, okay? Done, right? Let us see if it gives us the answer. What's the answer? What answer does it give you? Remember, I haven't multiplied by pi. So it gives me 0.516. That's 0.852. Okay, good. So what do I get? I'm going to have, this gives me pi times 0.80, what did we get? 8052, okay? 52. And when I multiply by pi, because it's a calculator question, so your answer times pi, answer times the pi. Okay, what do I get when I multiply by 267? That's 8, right? Good. So it will give me 2.68. That is it. I've got my, how many marks, guys? Wow. One more time. We check the question. 17 marks. That's paper 2 question. GDC, very important, vital, and very crucial. So you need to learn how to use your GDC. I'm planning to do 2 more questions on how to use your GDC. So very important. Thank you for watching my videos. EK Math, we love mathematics. Okay. Thank you very much. Good. Okay.